So I've left our formula here so that we can refer to it, and we've got an example to do. Now, the first thing I notice about this example is that I've got two different functions of x. So it's one of the tricky ones. Now I've got to check, if I differentiate what's in the brackets here, in other words, find f dash x, if this part is f of x, what will I get? Well, I'll get 2x. Ah, that's perfect. That's what I've been given out the front. So that seems good. Okay. So we've got the form that we want. We've got some function, x squared minus 5, raised to a power 7, and we've got f dash x out the front. So it's ready to go, and we're ready to apply this formula exactly as it is. So what do? Well, we need to put f of x, which is our x squared minus 5, but we need to raise it to the power of n plus 1. So we need to add 1 to that 7 and make it 8. And then we need to divide by the new power. Now, as with every single time you integrate, you should always differentiate what you get to check that it takes you back to where you started. So if I differentiate this, I know I have to bring the 8 down the front, and it will instantly cancel, disappear. And this will become a 7. So that's looking good. I'll have this part ready to go. But I also have to differentiate what's in the brackets and bring that out the front. So 2x will have to come out the front, which it was. So I'm good to go. Now, these get a little bit harder if what we're given here is not perfect. So let's have a look at how we can change it. For example, if we were given a question that was very similar, but it might have said 10x, x squared minus 5 to the power of 7 dx. Looking at this, I can see I've got x squareds here and x's here. So it's in a form I'm going to be able to manage with, but it's not perfect because I would like to have 2x out the front, and instead I've got 10x. What can I do? Well, I can account for it. I can change the question and say, gee, I really wish you'd given me this question. I wish I had 2x out the front, and then the x squared minus 5 to the power of 7 in brackets, because if you'd given me that, I'd know what to do with it, because the 2x is the differentiation of what's in the bracket, so I really would rather this, thank you very much. Now have a look at the question you want to do and the question that you've been given. How are they different? Well, this one's 2x and this one's 10x, so really this one is just 5 times bigger. So the question you want to do, you can just multiply it by 5, remembering that constants can be brought outside the integral. And that way you'll have 5 lots of 2x, that's the same as the 10x, and you're good to go. Now you know what to do with this part, so all you need to do this time is keep your 5 out the front and go ahead and apply your same formula. So you'll think, all right, what's the function that's in the brackets? It's the x squared minus 5. I need to raise it to a slightly higher power than what I was given, so that'll be to the power of 8, and I need to put it over 8. And in fact, in both of these, I've forgotten to add c, which hopefully you're watching and saying, Miss Stanton, add c, it's not finished. Oh, hang on, we don't need to do it yet. Here, plus c. Then when I get here, just double check that it's right. If I differentiate this, the 8 will come down the front and cancel, it's gone. The 5 will stay there. I'll need to take 2x out the front. So if there's already a 5 there, that'll give me 10x. Perfect. And the power will drop down by 1, so I've got it right. And now for one that's as tricky as what you're going to get. So on this one, let's look at what the function is that would have to be differentiated to be brought out the front. Our function's 1 minus x to the power of 4. Now if I differentiate that, I get minus 4x cubed. So what I want to integrate, and this is how I do this, I think, what do I want to integrate here? Do I want to integrate this? And write down the question that you want to do, and then change your question so it's the same as the one that you've been given. So I'm going to start by just rewriting the question. I'm not going to integrate anything yet. And I'm going to say, this is what I would like to integrate. I would really like it if what was at the front was minus 4x cubed, because if it was, I would have this pattern here, which I know what to do with. I want f dash x at the front of f of x to the power of something. So I've got that. Now, how's my question different from the one that I've been given? Well, it's got minus 4 in it at the front there. So I've multiplied by minus 4. Now, how can you undo multiplying by minus 4 or make up for it? Well, if I multiply by minus 1/4 out the front, a negative times a negative makes a positive, And a quarter of 4 is 1. In other words, minus a quarter of minus 4 is 1. So I've effectively got the same question that I've been given, and even though it looks a bit clunky, it's way easier to do because this part is the part I know what to do with. The minus a quarter, I just need to leave that hanging out the front. So now we can go ahead and do it. We've got minus a quarter, and then we know that we need to rewrite the function. So we've got 1 minus x to the power of 4, all raised to the power of something a little bit bigger than 7, which is 8. And then we need to divide by the new power, which is 8. So we've got minus a quarter. You can use a dot for your multiplying in there if you want to, or a times sign. Now I can just tidy up. I've got quarters and eighths on the bottom, so that I can just bring those together and make 32. And here I've got the negative out the front. There's a bunch of ways you can write this that are all the same. I'm just going to make it look tidy and do it like that. Some people might write minus 1/32 out the front and then put this, but I think that looks neat and tidy that way. Now I still need to, I've integrated, so I need to add c. Always remember when you get to the end, add a constant.